Hello class. In this lecture I will talk about hypothesis testing for comparison of two proportions. So here is the problem. The US Bureau conducts annual survey to obtain information on the percentage of the voting age population that is registered to vote. Suppose that 475 employed persons and 516 unemployed persons are independently and randomly selected, and that 250 of the employed persons and 195 of the unemployed persons have registered to vote. Can we conclude that the percentage of employed workers who have registered to vote is greater than, I think it's greater than the percentage of unemployed worker who have registered to vote? Use a significance level of alpha is equal to 0.01 for the test. So to solve this problem, the first thing is they gave us an information that P1 represents employed workers. So I will write P1 is equal to employed, and then P2 is unemployed workers. So in hypothesis testing, the first step of the hypothesis is to define your hypothesis. So we have a null hypothesis and then we have alternative. So they say, can we conclude, maybe I will use a different color. So can we conclude that the percentage of employed worker who have registered to vote is greater than the percentage of unemployed workers? So they are saying P1 is greater than P2. So that will be our alternative. So this can also be written as P1 minus P2 greater than 0. So our null on this side would be P1 less than or equal to P2. So this will be P1 minus P2 less than or equal to 0. So that will be our hypothesis. So once we have hypothesis, we have a set of data that is given. We will read the data. So this is all given. So the data given for employed workers and unemployed workers. So for employed workers, they say suppose that 475 employed persons and 516 unemployed persons are independently and randomly selected. So your sample size for employed is 475. So that is this one, and for the unemployed would be 516, that is this one. Out of those selected, 250 of the employed persons and 195 of the unemployed persons have registered to vote. So your x1 would be 250 for employed, x2 would be 195 for unemployed, and then they are asking us a significance level alpha is equal to 0.01. So your alpha would be 0.01. So this is the data given. So the second step of hypothesis testing, this was first. So the second step of hypothesis testing is to compare test statistic with critical value. So our test statistic we will be using, because it's a proportion problem and the sample size is high enough, like 475 and 516, we will be using a z-test. So z, the formula would be p1 hat minus p2 hat minus p1 minus p2 divided by square root of p1 hat 1 minus p1 hat divided by n1 plus p2 hat 1 minus p2 hat divided by n2. So from this, one of the things is we need to determine p1 hat and p2 hat. So what are these values? So to get p1 hat, I will do the formula is x1 by n1, so I will do 250 divided by 475. So the p1 hat I will receive would be 0.256. So if you do this, you should get 0.256. Same here, p2 hat would be x2 over n2. So p2 hat will be given as 195 over 516. So that would give us 0.378. So we got those values. So I will substitute those values. P1 hat is 0.526, 0.526 minus, so this is 5, minus 0.378 is P2 hat. So minus P1 minus P2, the value will be obtained from null hypothesis. So let's go and see. So the P1 minus P2 is 0. So we will do 0 here, and then square root of P1 hat is 0.526, 1 minus 0.526 divided by N1 is 475 plus P2 hat 0.378, 1 minus 0.378 divided by N2 is 516. So if you calculate this, the z on the numerator, you will get 0.148, and on the denominator you will get 0.0313. So this would be 4.73. So we have the test statistic value. So the next step would be to calculate the critical value. So this is critical value. So the critical value, for critical value we have to see whether our hypothesis is a one-tail problem or a two-tail problem. So if you see this is less than or equal to, that means you will be evaluating only one side of a normal distribution curve, so it is a one-tail problem. So that means you will do z alpha, that is equivalent to, your alpha is given as let's see what is your alpha, 0.01. So you are looking for value z 0.01. So let's see how this looks in a normal distribution curve. So if this is your normal distribution curve, P1 minus P2 is equivalent to 0, and then your hypothesis is P1 minus P2 less than or equal to 0. So what you do is, I will write the hypothesis here, maybe null hypothesis, P1 minus P2 less than or equal to 0. So you have a certain value and you are saying this area, maybe I will use a green color, this area is P1 minus P2 is less than or equal to 0. That means in this area your H null is true, or the other way of saying is, do not reject H null. And then we have this area. So this area is given, which is 0.01. So if this is 0.01, here P1 will be greater than P2. The other way of saying is P1 minus P2 is greater than 0. This is the area where alternative would be true. HA is true. So here you will reject your null hypothesis. Reject H null. So if this is 0.01, this area would be 0.99. So to get this point, because our z table gives to the left of the curve, I would be looking, instead of z 0.01, I would be looking at z 0.99. So the other way to get this is, when you look at your z at 0.01, you will get, so if this is 0.01, you will get z 0.01. This will be a negative value. You can just convert it into positive 0.01. So both will give you the same z 0.99 and then this positive 0.01. They will be both same values. So I prefer doing 0.99, so I will go and look in our normal distribution table or z table, the what is z at probability 0.99. So this is probability. So I will go to our canvas page, go to modules, and then in module 0 go to calculation aids. Okay, sorry, this I need to go to calculation aids. I think I'm doing this wrong. Calculation aids. Okay, I go to calculation aids and do chapter 11, calculation aids. Then open this. Do enable editing. Okay, so I'm in a wrong sheet. I think I should have gone to, I'm sorry for this. I think I should have gone to statistical tables. So I will download statistical tables. I'll do enable editing. Currently I am in Poisson table, so I have to go to Z table. So I go to Z table and look for probability 0.99. So I will go and look where is What is the z value at 0.99? So I go down and look at 0.99. So 0.99 would be either this or this. So that is 2.32 or 2.33. So I can use any of them. I will use 2.32. So my this value here would be 2.32. So this 2.32. So this is 2.32. Now I go and look for where does 4.73 lie. So where does this 4.73 lie on a number line? You have a 2.32. So in a number line, 4.73 is on the right side of 2.32, which is 4.73. So it falls under reject H null region. So we are saying reject H null. So if I am saying reject H null, that means this P1 less than P2, this statement is false. That means inherently this statement P1 greater than P2 is true. So the question says, can we conclude that the percentage of employed workers who have registered to vote is greater than the percentage of unemployed workers? That is a true statement because P1 is greater than P2. That is a true statement. So we are saying there is sufficient evidence to conclude that proportion of employed workers who register to vote is greater than the unemployed workers, than the proportion of unemployed workers. So this is how you solve the problem. I will use calculation aids to solve this same problem. So this is through calculation aids. Again, I will note down the given data along with hypothesis. So I'm going to note down from here until here all the values. So you can kind of note down. I have these values on a sheet of paper, so I will go and note down these values. So our H null is P1 less than or equal to P2. Our alternative would be P1 greater than P2. So this can be also written as P1 minus P2 less than or equal to 0, P1 minus P2 greater than 0. And the data given, again this comes from the question itself, which is from this portion to this portion. That is what I'm copying. I'll go. So this is given, which is for employed, and this is unemployed. So the data is for employed, N1 is 475, x1 is 250, n2 is 516, x2 is 195, and alpha is 0.01. So I will go and download my calculation aids. So this is, again I'm going to modules, and then I'm going to calculation aids, and then chapter 11 calculation aids. I will download it, and then I will open that and to enable editing. So this is a proportion problem, so I will go to proportion and key in these numbers. So first is sample 1, number of events, that is x. So for the first one, x is, for employed, x is 250. I'll use a different color, 250. So I will type in 250 here, and then sample size is 475. So this is 475. So you see you got your p hat value here. So again I will go and type in for sample 2. So let me see what is sample 2x, x2, that means x2. So x2 is 195. So this is 195, and then sample size, okay, I have to do undo. This is sample size, okay, so sample size is 516 here. So I will go and do 516. So this is 516, and then again we got p2 hat here. So alpha, I need to type alpha here. Let me see what is our alpha. Our alpha is 0.01. And so which case to use? So your test statistic is 4.69. Now which case to use? You will go look at p hat. How does it look? H alternative, not p hat, H alternative, how does it look? So I will go here and look for my H alternative. Looks p1 minus p2 greater than So I will go to the sheet, and P1 minus P2 greater than is this one, so I will use this. So my critical value would be 2.32, and I will reject H null. So that means I am rejecting H null. So I am rejecting this. This is false. So that means this would be true. So that means P1 is greater than P2. And again in this sheet you can find uh, if they ask you confidence interval questions, the critical value for the confidence interval in proportions would be this, the standard error would be this, and then lower bound and upper bound. You see, lower bound is 0.067 and upper bound is 0.229. So this is both positive numbers. That means your P1 is greater than P2. So these numbers represent the lower limit of P1 minus P2 and upper limit of P1 minus P2. If both are positive, that means P1 is greater than P2. So this kind of concludes my lecture on proportions. Thank you.